So now in this video, I'll be going over some topological sort problems and some LeetCode problems. So first is course schedule. This is LeetCode 207 and marked as a medium level problem. So in brief, the statement is given the number of courses and prerequisite pairs, determine if one can finish all courses. So the core idea or intuition is that we need to detect the cycle in the directed graph using Kahn's BFS algorithm, where we have to use the in degree vector or the DFS recursion stack. If topological ordering exists and includes all the nodes, then it is possible to be able to finish all courses. And the complexity is over v plus c because we are using topological sort or Kahn's BFS algorithm has a complexity of over v plus c. So this is the function can finish, which takes number of courses and the prerequisites vector of int type. So we make adjacency as the graph, which basically is in the form of an adjacency list. Vector int in degree, which is basically the in degree vector, which has a length of num courses, that is n is the size, and 0 is basically uh, the values initialized, right? So the in degree initially we have set as 0 for all of these nodes that we have for the graph, right? Let us say we have 6 nodes and we have 0 in degree initially. Now for auto p belonging to prerequisites, for each pair in prerequisites, we have basically pairs like u to v, right, in the adjacency list or basically in the prerequisite list. So if uh, this basically direction indicates that in order to complete course V, we need to complete U first, right? Since there's a directed edge from U to V, which means that V will be taken up as a course only when U has been completed as a prerequisite, because U is a prerequisite of V. So that is what we're doing. Adjacency of the V, that is the second one that is coming. Adjacency of V, we push back U there, and we increase the degree of U, right? And now we take a Q and apply the standard BFS algorithm for Kahn's toposort. So for int I is equal to 0, I less than number of courses I plus plus. This means that traversing over all the nodes, if in degree of I is 0, we push it into the queue, that node, that is I, and counter we keep is equal to 0 while queue is not empty. We extract the node from the queue's front and pop it out. So queue dot front, queue dot pop, and increase the counter because we have found one more node, that is node U. And now we're going to travel for further for all neighbors of U, that is the node. So for int v belonging to all the for int v basically for all the neighbors of U, if in degree of v becomes 0, so we reduce in degree of v first and then we check if in degree of v is 0, that is if in degree of the neighbor is 0, then we push it into the queue and we return if the number of courses, that is total number of courses, is equal to the counter, that is all the nodes have been covered, then we return true, otherwise we return false. Now course schedule 2 is the return the ordering of courses or empty array. So again the Kahn's algorithm, now we just need to return the topological order. So we basically have the same thing here, just have another order vector, right? And we keep pushing back the node that we are popping out from the queue. So order to push back u, and we check if order size not equal to num courses, then we return empty array, otherwise we return the order.